I want to explain why that formula works, and this is something I'm going to expect you to know for tests and stuff like that, if the magnitude of r is less than 1. And this is going to rely on this math trick, which I'll explain. Okay? So I want to show that this times this is equal to that, so I'll write this as the standard form for multiplication. Multiply by 1 plus r squared plus all the way up to rn with all the terms in between. Now I'm going to multiply minus r. Minus r times 1 is minus r. Minus r times r is minus r squared. Minus r times, here there's going to be an r to the n minus 1 here. Minus r times that is minus r to the n. And then minus r times this, minus r to the n plus 1. Now I add these two things together. This is times. This is addition. Cancel, 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 cancel. I'm left with 1 over that. So what that tells me is that this times this is equal to this. This times this, the same thing. Okay, I hope that makes sense. Now, if this is true, then what I can do is I can divide each side by 1 over 1 minus r, and I get that cancels, and I get this is equal to this. And this is the key idea in the proof, and you'll see why, I hope. Okay, so we're ready to go. So I'm going to start here. Oops. I want to see what this is going to be. I'm sorry, that's an infinity there. Whew. Okay, so this summation is equal to the limit of this. Remember this from class? The series is the limit of the partial sums. So I'm going to write this out. Get limit. N goes to infinity. I'm going to write this out. K is equal to 0. I get A R, which is just an A. When K is equal to 1, I'll put the R to the 0 there. When K is equal to 1, I get A R to the 1, and so forth. Finally, when K is equal to N, I get A R to the N. Okay. So this is equal to this limit, and I'm going to factor an A out here. Okay, well this is just this, with this equal r to the 0. Remember, this is equal to this. And this is equal to this limit. There's an A here. So I get A times 1 minus 1 over r minus rn plus 1 over 1 minus r. Okay, well, this is where this is key. That's less than 1, so recall, this is from class Thursday, November 6th, that lim r to the n equals 0 if r is between minus 1 and 1. That's the key. So that means this limit goes to 0. So we're left with equals this limit. Now, limit of a is a. Limit of 1 minus r, there's no end to it, is 1 minus r. So that's what we got. We got this. This is equaling this. So that's a big chain of equalities. Quick thing again, this is the key fact. We showed this is true. So I'll divide that down. Then I divided 1 minus r, so we got this is equal to this over this. We filed that away. Wrote out the series. It's equal to the limit of the partial sum. I wrote out the terms. Now this, I factored out the a, so I just focus on this. This is equal to this. So I wrote that. Two separate limits. We called the limit from class. This limit's equal to 0. So this whole thing goes to 0. And that's all I'm left with. When I take this limit, there's no ends anywhere, so it's just a over 1 minus r. This is equal to that. And I hope that makes sense. Good night.